is Paul, and we're going to be solving this question from the engineering mechanics textbook. I'll be solving all three of these questions in this video because they're quite easy. So it says, if the resultant force of two tugboats is 3 kilonewton, directed along the positive x-axis, which is along this area, sorry, it's blue and blue, determine the required magnitude of force Fb and its direction theta. So just to draw this out, we have, let me draw it up here, we have 2 kilonewton, we have Fb unknown, we have our resultant force which is 3 kilonewton. Now just simply going to draw the parallelogram. Let's extend this. Now we know that this angle is unknown. By extension, this angle is also the same as this angle, alternating angles. This angle is given as 30 degrees. Now I'm simply going to bring out this Pascal triangle. It's going to be just going to extend this. It's going to be 3 kilonewtons. This is 2 kilonewtons. This is 30 degrees. This is theta. Now this is FB. FB is going to be equals to, I'm going to use the cos rule. Square the other sides. Plus 3 kilo square minus 2 times 2 kilo times 3 kilo plus 30 degrees because that's the angle directly opposite to FB. Calculate this and you're going to get that FB is equals to 1.61 kilonewtons. Now for the angle theta, we're going to use the sine rule. Sine rule is simply going to be 2 kilonewtons over sine theta, that's 2 points, equals to the knowns 1.61 kilonewton over sine 30. If you make theta subject formula in all of this, you're going to get 38.3 degrees. That's the first one done. Now moving on to the second one, 2.29. If in this case we're given FB and we're given theta, we're told to find the resultant force and its direction measured clockwise from the positive x-axis, which means the resultant force is not on the x-axis anymore. So if we have our force FA, our force FB, our force FB is 3 kilonewton, this is 2 kilonewton, this is our imagined horizontal, this should be our resultant force somewhere around here. Yes, I'm supposed to draw the parallelogram. So resultant force will meet at this point. This is the angle. I use phi since they already gave us theta. This is our resultant force FR. Now we're given this angle 45 degrees. You can see at this point we're given this as 45 degrees. And this point, the horizontal is giving us 30 degrees. So that means the full angle here is going to be 75 degrees. Now I want to use the top triangle. I'm just going to draw it out here. This is 2 kilonewtons. This is FR. This is the dotted line joining them, which is FB, which is 3 kilonewtons. Now we need to find what this angle is in order to be able to do cos rule. This angle in a parallelogram, angles that are adjacent to each other must add up to 180. Since we know this side, we simply say 180 minus 75. And in that way, we can get that here is 105 degrees. That's 105 degrees. We're simply now going to carry out cos rule. FR is going to be equals to the square of the other two sides, it's kilo square plus 3k square minus 2 times 2k times 3k. By the way, k means 10 raised to the power 3 cos 105 degrees. If you punch it into your calculator, you get that FR is equals to 4.013 kilonewton. And for our degree, this point, which is from here to here, is 30 plus phi. I'm going to represent using alpha. We're going to solve for phi using sine rule. I'm going to say 3 kilonewtons over the angle we're looking for, sine, let's call it alpha, is equals to FR, which is 4.013 kilonewton over sine the angle we know, 105 degrees. Make alpha substitute formula and you're going to get 46.22. Now remember that alpha is equals to 30 plus phi. In order to find phi, which is the direction of the resultant force, we're going to do alpha minus 30, which is equals to 16.2 degrees. We've been able to get this and this. Now next, let's move on to the last question. I'm going to solve it here, which is 230. If the resultant force of the two tugboats is required to be directed towards the positive x-axis, which means the resultant force has to be on the x-axis. So this is FA, and the resultant force must be here, FR. Determine the magnitude of FR and FB. So the question is, at what angle will FB be minimum? Have you ever tried dragging a bucket from point A to B by lifting it up at point A and just standing there? So, sorry, that didn't really make my point. But if this point A, you want to move something to point B, you have to drag it in this direction, in a direction parallel to the path you want to follow. However, if you want to carry that bucket from point A to B, but instead you choose to carry it perpendicular at this point, that's 90 degrees, without moving, you're just here carrying the bucket. There's not going to be work done from A to B. That bucket is just going to be going up and down. FB to be able to exert minimum force, it has to be perpendicular to FR, 90 degrees. So now to find FB, it's going to be equal to, here's 2 kilonewtons. We're simply going to have a right angle triangle. It's going to be FR here, 2 kilonewtons, and FB at this point. This is 90 degrees. This is 30 degrees according to the photo. So therefore, FB is going to be equal to 2 kilonewton sine 30 degrees, which is equal to 1 kilonewton. And FR, by means of Pythagoras theorem, is simply minus 2 kilonewton cos 30 degrees, which is equals to 1.73 kilonewton. Thank you for listening.